Hello everyone, welcome to my channel on YouTube. Today I'm going to take a topic from Strategic Math series and let's see how we get the questions in different kind of competitive examinations, whether it's banking, PO, NTPC, Math League, Olympiad, any competition. Let's see how we can quickly solve these reasoning questions. I have displayed on the screen a triangle. This question I have taken from my Strategic Math series, the questions which I share with my students. So we'll start with that. It says it's like a figure given to you and you see triangles inside triangles inside triangles, and the question says find the number of triangles in the given below figure. Now, when we are working on the test day, we do not have time that, okay, now this is triangle 1, this is 2, this is 3, this is 4. No, we do not have time. We cannot do by this method, the actual counting method. It is not at all going to work. So what is the strategy here? Let's see that. I have displayed a simple example on the screen. I can name the triangle maybe ABC. Now, this is the triangle and it has some partitions which makes it into or divides the main triangle into some more triangles. So what is the strategy here is, it's very simple. Count these partitions. 1, 2, 3. Just name these partitions. I'm going to give you two strategies here. The first method, it says whatever is this number, okay, whatever is this number, multiply it with its next number divided by 2. I have here 3, so what is the next number to 3? It's 4. Whole divided by 2, which means 12 divided by 2, and my answer is 6. Okay, I'll repeat the process again. The answer is 6. I have total 6 triangles in this given figure. I'll repeat it again. What we will do here is we will count the partitions, and in this case the base is BC. Okay, this is the base where the altitudes or the triangles have started like splitting up, and A is the vertex, so it splits from A dropping up to the base BC, and I have 3 partitions, 1, 2, 3. Multiply whatever is this number here with its next number divided by 2. You will get the answer. In this case it is 6. Same page, I'm going to show you another method but in different colors so that you're able to see parallelly what will be the other method to solve these questions. Now, second or alternate method here is, I have 1, 2, 3, the splits given to me. Just add these splits, these numbers, and then it is again 6. Both the cases my answer is 6. Again I'm repeating the alternate method. Whatever is the number of partitions, 1, 2, 3, just add them. 1 plus 2 plus 3, that is the number of total triangles given in this figure. Honestly speaking, I prefer the first method, but whatever the method you are comfortable with, you pick that method, and I'm writing here alternate method. Now let's see next figure. We will work out the question. Now here I have another variation of the same kind. I'll name them as A, B, C and D, E. Now, previous was easy. We just had one base. Now here my base is D, E and B, C. Now you see I have this line as, and this line from where common vertex A is dropping the altitudes or splitting the figures. So that means we will have to count 2 times these number of triangles. I am going to work with the first method. I repeat, that's my method. I will do the first method of taking and counting the numbers, partitions, multiplying it by its next number, dividing by 2. You want to use the alternate method, you can definitely use it. So let's see. What I'm going to do for this triangle, I am talking about this figure first. I will make it a little big so that you're able to understand. Now, I will put the numbers 1, 2, 3, 4. Okay, and I'm just talking about this triangle first, ADE. Okay, triangle ADE. I have highlighted that. I have made the boundaries thicker so you can see. Now, what I am supposed to do, I'm writing, oops. I am writing triangle ADE equal to 4 times 5 divided by 2, which is 20 by 2, and here I have 10 triangles. Every step I'm going to change the color so that it's easy, it's prominent, and we don't mess up on any of the understanding part. Now let's talk about the another triangle or different portion. I have this triangle. Okay, I'll make it. I have this portion now, A, B, C. Forget about DE. Just think it is not there and we are working on this ABC triangle. I am writing triangle ABC. Now, partitions are how many? 1, 2, 3, and 4. Equal partitions, 4 times 5 divided by 2, and the answer is 10. Now, we are not yet done. The total triangle, it says, will be, I am writing here, total is equal to 10 plus 10, and final answer is 20. So I have 20 triangles in this figure. I hope it's clear. If you have any concerns, you can put your feedback in the comment box. Let's take another variation of similar kind. Now, interesting. This we have, you see how many bases do I have here, and the bases do not touch the whole lines, which means if I name them as A, B, and C, only at the base BC we have partitions like 1, 2, 3, 4, 5. Okay, this line, if I name it as, let's say, D, E, and I'm going to name it as F, G, H, I, and J and K. Now you see only on the base BC I have complete partitions, the splits. Rest it is in partitions. If you talk about DE, we will go gradually step by step. So let's first talk about the triangle ABC. With the names and the numbers, it becomes very easy for us to understand. So what did I say? How many partitions I have? 1, 2, 3, 4, 5. I am multiplying 5 with 6 divided by 2. So that gives me 30 over 2, and that is equal to 50. So this is 15 here. Now, I'll name them as 1, and I'll keep on changing colors. Now 2. Line DE. Okay, now DE will be the base, and I can name the triangle as ADE. ADE. Okay, I don't want to highlight it because it will become like a jumbled up. So I'm writing the names triangle ADE. How many? Now D is the base. How many splits I have? 1, 2, 3. Correct? It doesn't go up to the line AC. I will only count these splits. So I have 1, 2, 3, which means 3 times 4 upon 2, and that we just worked out is 12 by 2, and that gives me 6. So I'm underlining it. We will eventually add them in the end. Now I'm putting 3 for number GF. So the triangle we have AGF. Okay, the triangle AGF. And how many partitions I have? 1, 2, 3, and 4. So I have 4 partitions on the base GF. So what shall be the number? 4 times 5 upon 2, which will give me 20 by 2, and the answer is 10. I'll write it over here. Answer is 10, and I'll circle this. Now next is, we actually have 5 partitions here, so let's see. Now let's go to this triangle AHI. So I'm talking about this triangle. How many partitions I have? 1, 2, and 3. Now if I have 3 partitions, means 3 times 4 upon 2, which is simply equal to what? 12 upon 2, 6. Now the last step, not the last step, but the last triangle. The last triangle, I hope you know that this is a symbol of writing short form for the triangle. Just make a triangle, write LE, so that this is how I use for signifying the triangle shortcut. So now here we are talking about the triangle AKJ. This small portion. How many triangles? 1, 2, and 3. So 3 times 4 upon 2, we just worked out, it is 6. I will go to the next page and we will do the last step there. Total number of triangles are 15. Then we counted 6, 10, 6, and 6. So 6 plus 6 plus 6 is how much? 18. 18 and 10 is 28. 28 plus 15 gives you 43. So we have total 43 triangles in this given figure. That's your answer. In the upcoming sessions, I'm going to continue with the reasoning and the figure counting. You see, I have shown you 2 figures, which is like squares and then split into different partitions. So we will find out rectangles, squares, only rectangles, these kind of figures, then we will go into jumbled up, like combined figures basically. So I hope you're following this. Let me know if you have any concern or any issue. I hope you're enjoying these sessions. If you like them, share, subscribe, and keep learning, keep enjoying, sitting at home at your own convenient zone.